Alright guys, in this video we're going to check out some different functions. The first kind of basic thing that we want to talk about is this notation called function notation. So we're used to seeing things, and we'll talk a little bit more about what this is in particular as we go forward, but we're used to seeing things with x's and y's in them, pretty basic equations. It's got an input, and the input happens to be the x value. So we plug in x's, and when we plug in x's, that allows us to find out what the output is, or what the result is of our input. So our x values are input, our y values are outputs. Okay, and we're used to seeing it in this particular way. Well, there's another kind of little bit more advanced notation, and it's called function notation. And what this really is instead of a y here, we take this y value, and instead of a y value, we replace it with what's called f of x. F of x notation. Okay? And all this means is that this is a function. It's a function where it takes in inputs of x and spits out outputs. Now, for this one, our output is technically f of x instead of just a y. So it's really just a different way of writing the same thing, but it's a little more formal. You usually see a little bit more formally, or things written a little bit more formally in function notation. Okay, so just to move forward, we've got our f of x equals 3x minus 5. These are the inputs. Our inputs are x, so when we write our ordered pairs, our inputs are x's, and our outputs are actually, instead of y's, they are f of x's. So our ordered pairs actually look like this. Okay, so there are a couple different things that we want to be able to do with this function notation. So the first thing, and kind of the most basic, is we want to be able to evaluate a function, or find out what a function is worth for a particular input value. So we take this input value, this x, wherever we see an x in this thing, we're going to plug it in, and that includes right here. So the function notation looks like this. When x is 3, we say it is f of 3. So that's exactly how it's pronounced, f of 3. And all that means is when I plug in 3. So we say f of 3 equals 3 times, and I see another x up here, so I replace that, 3 minus 5. So if I simplify this right side, the f of 3 just kind of stays the same, and I get f of 3, or in other words, when I plug in 3, my output looks like this. 9 minus 5 equals 4. Again, just to reiterate, this is your input, 3 is the input, or x. Oop, there we go. And the 4 is the output. So again, if I were to write my ordered pair here, my point, it looks like this. The thing I plugged in is 3, so that's my x coordinate, and my output, my y, or my f of 3, is 4. So that just gives me a location on this graph, and we'll plot that here in a second and take a look at this. Let's do a couple more of these. I want to look at what f of negative 1 is. Or in other words, I want to plug negative 1 in and see what my function is worth when x is negative 1. So same thing. 3 times negative 1 minus 5. So f of negative 1, well, when I plug negative 1 in, it's going to spit out a negative 8. My function has a height, or an output, of negative 8. One more time, this is the input, this is the output. So my ordered pair looks like this. When I plug in negative 1, it spits out a negative 8. Remember, these are just x, y coordinates. So this is my x, this is my y, this is my x, this is my y. And last one, we want to look at f of 4. And f of 4, when I plug 4 into that function up here, wherever I see an x, I'm going to replace it with a 4. So that's equal to 3 times 4 minus 5. So f of 4 is equal to 7. And again, I get my ordered pair 4, comma 7. That's a location in space. Okay, so evaluating a function is really just taking an x value, plugging it in, and then figuring out what the corresponding y value is for that x, or f of x. So let's go down and plot these points. So my first point is 3, 4. So just plotting points, I'm going to go over 3. Remember, this is the left and right axis. That horizontal axis is the x-axis. So I'm going to go 1, 2, 3, and then up 4. 1, 2, 3, 4. Here's my first point. There's a point right there. My second one is -1, -8. I'm going to go down a little bit here. -1, -1, 2, 3, 4, 5, 6, 7. I need one more. 8. And then we got one more. It's at 4, 7. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And then up one more. Looks like it's about right there. And so we plotted our points. We plotted our coordinate pairs here. 3, 4, -1, -8, and 4, 7. And again, all we did was plugged in x, use that function notation, figure out our y that corresponds to it. So let's go down here and check out what this thing looks like. Well, hopefully this function looks familiar to you. So this function here, we'll just have it handy with us here down below so we can kind of remind ourselves what this is. So f of x equals 3x minus 5. And if I draw a line right through these points are actually on the same line. And if you remember, this is the graph of a linear function. This is one form that you can put a linear function in. And so I want to check out what's the relationship between these points. So let's take a look here. So if I went from my first point, and I want to see how far up did I have to go to get to the same level, and how far over did I have to go to get to the same level. And it looks like if I go from -8, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to get to this point here. So this side, I had to go up 12. And then I had to go over 1, 2, 3, 4. And those are over right in the positive direction, 4. And if you remember, if I look at the ratio of how far vertically, so the change in the vertical, or what we call the rise, vertical change, and I write that as a ratio of vertical change to horizontal change. Or some of you might recognize it as rise over run. Then my fraction looks like this, or my ratio looks like this, 12 to 4, and we know that we can simplify this. 12 divided by 4 is just 3. So my rise over run, or in other words, my slope of this particular line equals 3, or 3 over 1. And that can be found right here in this equation. Okay, so I've got this thing tells me the rise over the run, or the slope of my line. And then the other thing that you notice is right here. This number over here is going to tell us something about the line too. The -5. If I go down 1, 2, 3, 4, 5, my line actually crosses right at -5. So that point is 0, -5. That's called the y-intercept. And this is going to indicate where my y-intercept is. Okay, so we figured some stuff out. We figured out that this thing actually tells us where the slope and the y-intercept was, or is, for this particular line. And so in general, what we're looking at is anytime you look at the coefficient of x, so whether it's in function notation or just y equals mx plus b, this one's probably the one that's more familiar to you, the number or the coefficient of x is the slope. That tells us the slope of the line. It tells us rise over run. So it tells us how far it goes up compared to how far it goes over. And then the other thing that it tells us is the y-intercept. So the y-intercept for both of these is going to be that number, that constant that's by itself. Okay, so just a couple quick examples I want to show you, maybe some special cases. So slope-intercept form is what this thing is called, and the reason that it's called slope-intercept is because it gives us the slope and it gives us the intercept. of a particular line. So we want to be able to graph these things, and we want to use slope and y-intercept in order to do that. So let's check this out. Hopefully we'll go through pretty quickly. So we know that the number in front of the coefficient of x is -2, and we can actually rewrite that as -2 over 1. We can rewrite any whole number like that. So in this particular case, -2 over 1 is going to be my slope. That means it goes down 2 and right 1. Okay, my y-intercept then, in this case, and we have to carry the sign with that number, that's going to be my y-intercept, and that is my b. So b in this case equals -3. And in order to graph this, I just go down to the graph here. I plot my y-intercept first. So my y-intercept is down 1, 2, 3. There's my point, my y-intercept, and then my slope tells me to go down 2, right 1. So if I'm going to do that, I go from this y-intercept, I go down 1, 2, and right 1. There's a point. If I do that again from this point, down 1, 2, right 1. That's going to give me another point, and so on. And we can actually do this in the other direction. If we went up 2 and took that negative and applied it to the bottom piece, or to the denominator of this thing, if we went up 2 and left 1, or 1 in the negative direction, it's going to stay on that line. So it actually doesn't matter where you take the negative, where you apply the negative to the top or the bottom, just as long as you apply it to one and only one of them. So we can plot our line in that way. And our line's going to look something like this. And we know that lines continue on forever, so we should have little arrows on each end of it. So it looks something like this. There's my line. Okay, so quickly, over here, let's go ahead and identify the slope. The slope is going to be -3/2. My y-intercept, or my b, is going to equal +5 in this case. So let's take a look at what happens here. So I go up 1, 2, 3, 4, 5. There's my y-intercept. And then my slope is -3 over 2. So again, apply the negative to one and only one of the 3 of the 2. So I usually take it to the top. I'm just kind of in the habit. So I'm going to go down 3 from my point. 1, 2, 3. And then +2. 1, 2. There's a point right there. Down 3 more. Right 2. And that's enough to get my line. So my line looks something like this. And again, we need our little arrows on each side here to make sure that it's clear that it continues on forever. Okay, so 2 more quick examples. So we know that when it's in this form, we know that the number in front of x is the slope, and the constant that's by itself, the number that's by itself, is the y-intercept. But sometimes you have to get it in that form in order to use those rules. So if I want to get it in that form, that means if you look up at this equation is solved for f of x, or in other words, it's solved for y. So I need to get y by itself. Okay? So the first thing I need to do is solve for y. I need y equals. And if I can get y equals, or y by itself, then that allows me to then pull out the slope and pull out the y-intercept. So let's go through this real quick. Hopefully this is pretty easy at this point for all of you. I get y equals -3x plus 5, and now I've got it in that form. So I know my slope is going to equal -3 over 1, and my y-intercept is going to equal 5. Go down and plot it real quick. 1, 2, 3, 4, 5. -3 over 1 tells me to go down 3 over 1. There's my 2 points. We only need 2 points for this line. And plot it, and you're done. So there's my line for that first one. So again, the key here is we've got to get it into this form, the slope-intercept form, before we pull that slope and intercept out. So one more quick example. This one's a little more involved. So I've got a 2/5 y, and I'm going to kick this over. So again, I'm solving for y. Solving for y, because I need y equals mx plus b. So I'm going to subtract 3 from both sides. -3 minus 3. That leaves me with x minus 3. And then how do I undo a 2/5? Well, the inverse of that thing is going to be 5/2. And that's going to undo that 2 fifths. So that'll get that to cancel. But then I have to take this over and I have to multiply this side by 5 halves. So over on the left side, I'm good. I've got my y equals. Over on the right side, I've got to distribute this out. So I'm going to have 5 halves x when I distribute here. And then this thing, I need 5 halves, do this over on the side, times a negative 3. And that's a negative 3 over 1. And how I do this, I'm going to multiply across. So that's negative 15 over 2. And I've now got it in that y equals mx plus b form, so I can pull out my info. So I know my slope is going to be 5 halves. And I know my y-intercept, remember we got to make sure we carry the sign with it, is going to be negative 15 over 2. So negative 15 over 2 is 7.5, so let's go down 7.5. 1, 2, 3, 4, 5, 6, 7. We got to extend this a little bit. So there's my y-intercept, somewhere down there. And then my slope is going to be up 1, 2, 3, 4, 5, right 2. There's 1 point. Up 1, 2, 3, 4, 5, right 2. There's 2 points. So plot that, and you're pretty much done. Okay, so we've got our lines. Big thing is make sure that we need y equals x plus b. And if you don't have that, you need to make that scenario so that we can then identify the slope and the intercept.